2 and 3 both appear to be barred spirals. They have a rather elongated central bulge shape. 4 looks more like a regular spiral. It doesn't seem like its bulge is elongated. And then 5 is an elliptical galaxy. No spiral arms are apparent in 5, and neither is a disk or any dust or any other, markers that would make us think it's a spiral. Some of the evidence that you correctly pointed out are that there's star formation regions that are happening all over this image. These are all marked by the blue arrows here, 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 and here. And then the tidal streams, I think this is what you mean when you say it looks like there's material being pulled around, right? And so these are the tidal streams that we're indicating here with the green arrows. It's probably a little bit hard to make out in the small version of the image, but you can see there's a blue tint to these streams, especially these ones down here. And even up here, you can, if you have a good enough screen resolution, you can make out some blue splotches in those tidal streams. So that's more evidence of interaction. When we think about distance to all these galaxies, in galaxy 1, we can actually very clearly make out individual stars, right? All these little blue dots. And so we would expect that 1 would be actually a lot closer for that reason. And so it's probably not part of this interacting system, even though because of all the blue and red, we can say that this is an area of active star formation. It just happens to be a spiral much closer to us. And we can corroborate that idea by actually looking at the redshifts of all the different galaxies. And these galaxies 2, 3, 4, and 5 are all part of the same cluster. They're all at about the same redshift, but galaxy 1 is much closer. It has a small redshift compared to the others. So this is the type of task that you would do to figure out how galaxy collisions are happening now. And the reason that we're so interested in collisions is because we want to form a full model of how galaxies evolve over time. So images like that are good evidence for our hierarchical merging model. We see that mergers happen today. And actually, we can look back in the past and see similar, but of course, much fuzzier evidence of the same process happening. So a lot of these images have multiple cores. You can see the connections between them. The smoothness of those connections suggests that they're gravitationally linked. And I've got a video to show you. I'll drop you the link in case it doesn't stream well for you. And I'll stream it. Hopefully gives you an idea of what would be the result of such a merger. So based on what you saw in the video, which of these merger outcomes do you think seems like the least likely scenario? All right, I'm seeing the most votes for D. I'm wondering if someone wants to explain why you think that's the least likely outcome based on what we've seen in the video. So in the video, it seemed to me at least like the two cores were coalescing together into basically an elliptical shape. And the disk was being just torn apart and disrupted completely. So it wasn't really forming a new spiral galaxy, even though it started out as two spiral galaxies. So what we saw in the video, I guess, is more like this scenario, scenario A. And I don't think there's a huge reason to believe that we would get anything other than elliptical by combining two ellipticals for the same reason. So maybe it's possible that we could trigger star formation, but ellipticals don't really have a disk, right? So there's kind of nowhere for those spiral arms to live. Kind of for the same reason as scenario A, scenario B seems likely if we combine a spiral with an elliptical, we'll probably get another elliptical. Basically everything here is ending in elliptical, for better or worse. So option D was indeed what I had in mind. This is the leading hypothesis, but it's possible that there could be spirals that could form from the mergers of ellipticals, but you would have to have particular conditions. You would have to have, maybe the lenticular galaxy, the type that's kind of between elliptical and spiral that almost has a disk. Maybe if that was one of your ellipticals, maybe that could then form spiral arms, but it's kind of hard to defend based on what else we've seen. All right, so the bigger idea here is that these mergers tend to destroy structure. Unfortunate because spiral galaxies are so lovely. But when we do have mergers, the simulations tend to show that they end up as ellipticals, at least if you're starting with two high mass galaxies. The situation is different if one of the galaxies is much larger than the other. So like if you have a spiral, like our Milky Way and a dwarf galaxy, the Milky Way is going to incorporate the dwarf galaxies that it's tearing apart without losing its structure because the dwarfs are so small in comparison to the Milky Way.